Hello guys, welcome to our today's tutorial. And today we are going to look at composite material, how they behave under loading. The question is, a concrete column 4-meter high and 400 millimeter by 200 millimeter in section is reinforced with 6 number 20 millimeter diameter steel bar. We have to calculate the safe axial load that can be applied to the column if permissible stresses are limited to 7 Newton per millimeter square for concrete and 140 Newton per millimeter square for steel, and also to calculate the change in length that will take place in the column under this load. You have to take Young modulus of steel, 210 kilonewton per square meter, and Young modulus of concrete as 14 kilonewton per millimeter squared. I hope you will enjoy, but before then, please just subscribe, like, and share my YouTube channel. That is the sketch of the column, just a rough sketch. Now, step number 1, we shall determine the area of steel bar. That will be equivalent to 6, which there are 6 in number, multiplied by pi times diameter of each over 4, because you know their area is given by pi d squared over 4, but they are 6 in number, which will give us 1884.96 millimeter squared. Now, the area of concrete, this will be equivalent to the total area of column minus area being occupied by steel. Total area of column is 400 by 200. Then minus area of steel, we've gotten it as 1884.96 millimeter square. This will give us the area of concrete as 78,115.04 millimeter squared. We've been told that the permissible stress in concrete is 7 Newton per millimeter squared. Now, what we shall do, we shall say, let the safe axial load be capital P, in that we know that if I want to compute the stress in concrete will be equivalent to the axial load multiplied by Young modulus of concrete divided by the sum of area of concrete times Young modulus of concrete plus area of steel times Young modulus of steel. If I substitute, I will use the permissible value and say, instead of stress in concrete, I will put 7 is equivalent to P, which is the assumed axial load, times 14 kilonewton per millimeter square. I'm multiplying it by 10 power 3 to convert it to Newton per millimeter square, because this value of stress in concrete is Newton per millimeter square to have uniform units, divided by the area of concrete was 78,115.04. I multiply by the Young modulus of concrete is 14 kilonewton, but I told you I multiply by 10 power 3 to convert it to Newton. Then I add on area of steel, which is 1884.96 multiplied by the Young modulus of steel, which is 210 kilonewton, but changing to Newton, I multiply by 10 power 3. So I will get the value of axial load that will achieve this permissible stress in concrete will be equivalent to 744.73 kilonewton. Then on the other hand, I will also have the formula stress in steel is equivalent to the axial load I've assumed multiplied, which is P, I multiply by Young modulus of steel, then I divide by area of steel times Young modulus of steel plus area of concrete times Young modulus of concrete. But we know that permissible stress in steel was 140. This will mean 140 is equivalent to P times 210 times 10 power 3 divided by area of steel times E of steel plus area of concrete times E of concrete. So that will end up to 992.97 kilonewton. So the axial load in terms of concrete is 744.73, And for the case of steel is 992.97 kilonewton. So when we have these two values, we always go for the least value, the smallest value, because if we adopt 992.97, it means the value of stress in concrete will exceed what is permitted or what is permissible. So for this case, we will conclude and say the safe axial load that can be applied to the column is 744 kilonewton. We take the lowest value of the two. Among the two, you pick whichever is the less. Then part 2 wanted us to compute change in length. Remember strain, because they are acting monolithically, strain in concrete is equivalent to strain in steel. And strain is given by stress divided by the Young modulus. Now remember the P we have taken is the one the concrete is subjected to. Now due to that, we shall calculate strain in concrete. And this will be equivalent to strain in concrete will be stress in concrete, which is 7 divided by the Young's modulus. Remember 7 Newton per millimeter square, so I will convert my Young modulus to also Newton per millimeter square because strain, it has no value, so which is 0.005. And then, but I know that for me to get strain, I can also get it through taking the change in length divided by the original length. Remember, we've been told this column is 4 meters. So 4 meter, or rather 4,000 millimeter, is our original length, which is capital L. And then we have our strain, which is 0.005. So we just say 0.005 is equivalent to change in length we don't know over 4,000. And the change in length that will occur in this column under the load of 744 kilonewton will be 2 millimeters. Thank you for watching. Please subscribe and share my YouTube channel. Thank you. See you then.